Okay, here are the last problems, 13 through 17. They are about arc length and sector area. So we have some formulas that you should know. There is arc length equals radius times omega. Sorry, that's theta. If theta is in radian, so if it's a radian angle measure, we're using this formula for arc length. Okay, S stands for arc length. Arc length, there we go. Okay, that's what S stands for. R stands for radius, theta stands for your angle. Okay, if it were an area of a sector, right, so this is sector area, that's 1/2 of r squared theta if theta is in radians. So if we have a radian angle measure, then you should use a radian angle formula. Now, what if we have a degree? Well, there you have a ratio. So S over 2 pi r, the total circumference, equals your central angle over 360. Okay, notice we have our angle in degrees. If you're trying to find an arc length over 2 pi r, right, that is the circumference formula. At a sector area is area over pi r squared. That's your circle area formula, over 360 degrees. Okay, so those are your formulas that we should know for arc length and sector area if we have radian angle measures on tops or the angles are in degrees on the bottom. Okay, so our first problem we have to do is add in a radius, and I told everyone in class that we should put a radius of 6. So let's do all these problems with a radius of 6. So find the following thing. This is arc length from A to B. So we're figuring out what is the length of this arc from A to B. Okay, so it's arc length over 2 pi r equals the angle. The central angle is 70 degrees. Equals 70 over 360. Okay, so let's just cross multiply. First, we're going to leave it in terms of pi. So I'm going to say 2 times 6 times 70. Okay, that's 840 pi over 360. Okay, so if we were going to reduce this, we can get rid of the zeros. And 84 and 36 are both divisible by 4. Oh, they're actually both divisible by something bigger than, how about 12? 84 divided by 12, that's 7. So it actually reduces to 7 pi over 3 when I divide both of these by 12. 12 is the GCF between 84 and 36. So 7 pi over 3 is the exact value. But if you want to decimalize it, 7 times pi divided by 3 is approximately 7.33 units. I guess centimeters maybe, whatever. I didn't say a unit, but 7.33. Okay, from B to C to D means we start at B and go around to C and then all the way around to D. So I need to know the angle for this whole entire thing, which I am missing part of. So to find that missing part, I subtract the other angles I know from 360. 360 minus 82 minus 70 minus 116 is 92. So 92 plus 116 meaning we have a total angle of 208 degrees from B all the way around to D. So BC over 2 pi 6 equals 208 over 360. So 2 times 6 times 208 is 2496 pi over 360. Okay, which if you have an Inspire calculator, that can help you really easily reduce that. But let's just take it as a decimal. multiply that and divide, and I get an arc length of 21.782 from B all the way around to D. Okay, now I want an area. What is the area of, I guess that's not really a sector, is it? That's not a very good, I should write AMB. That's what it should be. So I can find the area of this sector from A to M to B. Okay, so a sector is like a slice of round pi. Area over pi r squared. So pi 6 squared equals 70 over 360. Okay, so with an area, we have to use an area formula, pi r squared. So 70 times 36, that's what 6 squared is, times pi divided by 360 means the area of this sector is 21.991 square units. Remember, area is always a squared unit, so put your square units on area. Okay, so those are some formulas for arc length and sector area. Pretty simple, maybe, who knows? Okay, the area of a sector is this. So there's our area. If the radius is 20, what's the central angle in degrees? So if we want it in degrees, we're going to use our standard formula. All right, 3042.754 over pi 20 squared equals theta over 360. Okay, pi r squared. Remember, we have an area. So the area of a sector means we have an area formula. So let's do this. Let's take 360 and multiply it by 342.574. That's 123,391 and change. And then we're going to divide that by 400 pi in parentheses. If you don't do it in parentheses, then your calculator will mess up your calculations. So we have to divide it by 400 pi in parentheses so that it knows that 400 pi is the total denominator. So this has an angle, a central angle of about 98.2 degrees. Okay, it says it's in degrees. We used a degree formula, so our answer is going to be in degrees. Okay, pretty good stuff. An arc has a length of 15 pi centimeters. If the central angle is in radians, okay, so now we're going to use our radian formula, S equals R times theta. So 15 pi equals R times 7 pi over 8. Okay, so I know that we want to use it, well, maybe we can, who knows. The first step is to multiply by 8. Okay, multiply by 8 to get rid of that fraction. 8 times 15 is 120. So this now becomes 120 pi equals 7 pi r, right? I'm just going to rearrange and put r last. So when we divide both sides by 7 pi, the pi's divide out nicely, and we're basically looking for what is 120 divided by 7. And that rounds to 17.142 or 143. And the units are centimeters. So if we have a angle in radians, we use a radian formula. And if you have angles in degrees, you use degree formulas. So hopefully that is a good refresher, and you will do great on this portion of your test tomorrow.